Welcome to Nimu's World. It's me Nimesh Naik. Today I am discussing CSR Net Questions June 2019. Topic Topology. It's a part B question. Let A be a non-empty subset of a topological space X. Then which of the following statement is true? Option number 1. If A is connected, then its closure A closure is not necessarily connected. And option number 2, if A is path connected, then its closure A closure is path connected. And option number 3, if A is connected, then its interior is not necessarily connected. And option number 4, if A is path connected, then its interior is connected. So we want to verify which of the following statement is true. Now we are going through the option. Before going to option number 1, we want a result. So result, the closure of a connected set in a topological space is connected. Then our first option says that if A is connected, then its closure A closure not necessarily connected. But our result says that the closure of a connected set in a topological space is connected, which is always connected. So by this result, our first option is a wrong option. Now we are going to the second option. For solving second option, we want some result. So result, let A be a non-empty subset of a topological space X. If A is path connected, then A is also connected, but the converse is need not be true. That is, A is connected does not imply A is path connected. Our second option says that if A is path connected, then its closure A closure is path connected. So we want to verify whether it is true or not. So given A is path connected, A is path connected implies that A is connected by our result. If A is path connected, then A is connected. So A is connected, which implies that A closure is connected. This is because we say in option number 1 there is a result. The closure of a connected set in a topological space is connected. So we get A closure is connected. A closure is connected does not imply that A closure is path connected, because we say that A is path connected, then A is connected, but the converse is need not be true. So in general, we cannot say that A closure is path connected. For verifying, we take just an example. For an example, consider the topological sine curve. The topological sine curve is like this. Y is equal to sine 1 by x. So in this we seen that in a neighborhood of 0, the curve is oscillating many times in between 1 and -1. So this curve is connected, but it is not path connected because in A the region in between 1 and -1, that is the y-axis, does not included here, but we take the A closure, the region, the y-axis between -1 and 1 is included in that curve. So we say that that region is not path connected by simply verifying the graph of this curve. So we get A is equal to set of all x comma sine 1 by x such that x belongs to R is path connected, but its A closure is not path connected. So we get an example which is path connected, but its closure is not path connected. So our second option is also false. Now our third option says that if A is connected, then its interior is not necessarily connected. So for this we take x is equal to R square be the topological space, and A is equal to set of all x minus 1 all square plus y square, which is less than or equal to 1, union x plus 1 all square plus y square, which is less than or equal to 1. And also this is a circle with a center 1 0, so the figure like this, and this is the circle with a center -1 0, so like this. And also from the figure it can be the point 0 0 is included in A, so we can say that A is connected. Now we want to verify whether A interior is connected or not. So A interior is equal to set of all x minus 1 all square plus y square which is less than 1 union x plus 1 all square plus y square which is less than 1. The figure be like this. From this we can say that the point 0 0 is not included here. So this is not connected. So we can conclude that A interior is not connected. So our option 3 says that if A is connected, then interior is not necessarily connected. So we get an example, so which is satisfying the given condition. So our third option is a correct statement. Now we are going to the fourth option, which says that if A is path connected, then its interior is connected. So we have A is path connected. Path connected implies that we know that connected. So A is path connected, which implies that A is connected. Then by the above example, we get which is A is connected, but A interior is not connected. So by the previous example, we can directly say that our fourth option is false, because our fourth option says that A is path connected, then it is interior is connected. But we get an example in which A is path connected, but its interior is not connected. So our fourth option is also false. So our correct option is option number 3. Okay, thank you. If you like my video, please subscribe my channel and also share with your friends and like.